What up, what up, what up, everyone? It's a great day to learn some science. It's Mr. Haddock here, and today we are going to start our new unit section. We're going to start Unit 2, Section 2. The standard we're going to start off with is 7E 1.4, which is, in summary, predicting weather conditions based on information that we obtain from various sources, such as observations, measurements, weather maps, radar, and different cloud types. So really what we're going to be doing is taking a lot of our previously learned information and now applying it into making weather predictions. So let's get out our online notebook. Make sure that's opened up in a separate tab. Please title this section 2.11, and it is titled Reading a Weather Map. So we're going to start off with some important terms. Some of these terms you may know already, and that's okay. I am completely understanding you do not have to write all of this down. Write the things that you feel you need to write down. So if you know one of these terms already, there's no need for you to type it in your online notebook. But let's get through these. So the first word that we're going to take a look at is a meteorologist. This is a person who is an expert in predicting weather. You will see these are the people on the local news stations giving us the daily and weekly weather updates. And they take all the data and make it palatable or understandable to the mass public, which is a very important thing to do for keeping people safe. The second term is radar. Radar in a weather sense is used as a tracking system to determine the location and velocity of storms, clouds, precipitation, and other weather events. Radar has saved countless numbers of lives, especially when it comes to thunderstorms that have the possibility of creating tornadoes and things like that. The next term is forecast. You will see this a lot. Your 5-day forecast or your 7-day forecast in weather talk, and it just simply means to predict. A forecast is a prediction. The next term is humidity. Humidity is the amount of water vapor that is in the air, that is evaporated in the air. And that is typically given as a percent. The relative humidity is the comparison between how much water vapor is actually in the air, and they're comparing it to the amount of water vapor that air could hold at that specific temperature. So what is the maximum amount of water that air could hold at that temperature? And let's compare it to the amount of water vapor that is actually currently in the air. The next term is isobars. Isobars are lines on a map that connect areas with the same air pressure. And we'll cover this in a later slide in a little bit more detail. And finally, dew point. Dew point is the temperature at which water begins to condense out of air masses. The higher the dew point, the more moisture that is in the air, which can be very useful for predicting weather, knowing how much moisture is in the air. So let's go back to isobars a little bit here. Isobars, remember, are the lines on the map that show us equal or constant air pressure in a specific area. This map is showing us, I believe, Australia. And air pressure on a map like this is measured in millibars. Sometimes you'll see it measured in inches mercury. The Things that you need to look out for is where there's the lowest air pressure, you could expect things like precipitation and cloudy weather, whereas areas of high air pressure, you would see clear skies, clear and sunny skies. When isobars on a map are close together, you can expect windy conditions. So for example, I see two areas on this map where I would expect windy conditions. And that first spot would be right here. You can see that those isobars are really, really close together. And the second spot is right there where the isobars are relatively close together. Now you'll see numbers, and what you'll notice is these numbers, that is your millibars. And so all along this line, the air pressure is 1,036 millibars. Okay, and then something like along this line, the air pressure is 1,040 millibars. Sorry about those lines. Those are quite bad, actually. Anyway, moving on. Let's talk about high and low pressure. Let's start off with low pressure. Low pressure is caused by warm air rising. And you can see over here on the right-hand side, the image on the left there shows warm air rising, creating a low pressure system. Low pressure systems bring cloudy, breezy, and stormy weather. They are represented on weather maps as a red capital L. High pressure systems, on the other hand, are caused by cool air sinking, and you can see the cool air sinking to the right of that diagram. High pressure systems bring clear skies and cooler weather because the cool air is sinking. They are shown on the map as a blue capital H. And the final thing that you need to remember that's very, very important is that air travels from areas of high pressure to areas of low pressure. So you can see that this arrow right here is showing the air travel from that high pressure area to the low pressure area. So please remember that. That is a very important piece of information. Let's quickly review fronts so that you guys have a great understanding of what type of weather is associated with fronts, as well as an idea of, or a better idea of how they function in weather. So remember, a cold front is when colder air replaces warmer air. On a cold front's logo or a symbol, the arrows point in the direction that the front is moving. So the front would, on the right-hand side of your screen, would be moving in the direction of the triangles. Cold fronts tend to create thunderstorms just ahead of them. And after the thunderstorm passes, you will notice cooler air with mostly clear skies. It replaces the thunderstorm once the thunderstorm has passed. So you can see right here in our little image, you'll see a cold front forming a cumulonimbus cloud, which is our thunderstorm cloud, producing pretty heavy rainfall, some lightning, and possibly some tornadoes. And you can see on the top image here, we have a great visual to show us, okay, well, on the right-hand side of that cold front, the temperatures would be like 54 to 62 degrees. But on the left side of the cold front, the temperatures are much cooler at 28 and 31 degrees. So you can see a huge difference in temperature before and after the cold front passes. So that kind of helps us, and the thunderstorms would be just in front of that cold front right there. Okay, so that's how that works out. When air pressure drops, that is a sign that a cold front is on its way. Okay, because remember that warm air is rising right in front of that cold front. Okay, so that would be an area of low pressure right along that that cold front, bringing on the stormy weather. Now, the warm front is when warm air replaces cold air. Okay, and it's almost the complete opposite in the way it functions. It is represented by red semicircles, and again, they point in the direction that they point in the direction the warm front is moving. Warm fronts produce clouds and some precipitation in front of the warm front, and after the warm front has passed, it is followed by warm, humid, and clear conditions. So it brings warmer weather with more moisture in it, and clear skies. And you can see the temperatures have been reversed. On this side, on the right-hand side, you'll see 31 and 28. And on the left-hand side of the warm front, behind it, you'll see the temperature 62 and 54. So you can expect a temperature increase when you see a warm front coming. Rising temperatures and humidity is also a sign that a warm front is on its way. So those are two ways to identify a warm front is on its way. A stationary front is quite simple here. It's when two air masses meet, but neither one overtakes the other. What ends up happening is mild, moist airs on one side of the front, on the warm front side, and cool, dry airs on the cold front side. And neither one overtakes the other. Clouds are possible with stationary fronts, and precipitation is possible as well. But typically, it's not a very active type of front. Eventually, it will either turn into a warm front or a cold front. But there are times where neither air mass overtakes the other. And the last thing you need to know about stationary fronts is winds run parallel to the stationary front. So you can see that those arrows along on the right-hand side, those are representing wind, telling us which direction that the wind is moving. In the stationary front, you can see that they are parallel to the stationary front. The final one is the occluded front. This is caused when a cold front catches up to a warm front. They form when cold air, cool air, and warm air all collide. And they are a symbol that a severe storm is weakening, or a storm system is weakening, and losing strength. So typically with occluded fronts, there is severe weather associated with them. Now we're going to get into the nitty-gritty. So now that we have kind of reviewed high and low pressure systems and the type of weather associated with fronts, we can now take a look at the types of weather maps. So there's quite a vast number of weather maps. And let's start off with the list of all of them. You have short-range forecast maps. You have medium-range forecast maps, precipitation amount maps, chance of precipitation maps, temperature maps, wind speed and direction maps, and sky coverage maps. These are all useful in their own ways in helping to predict weather for a particular area. So let's take a look at the short range and medium range forecast maps. So on the left, you'll see the short range forecast map. These show pressure systems, high and low, fronts, cold, warm, stationary, occluded, and types and extent of precipitation. So they can tell you how much rain to expect for a particular area. And you can see down in the bottom left-hand corner, the different colors are associated with the amount of or the type of precipitation, as well as the likelihood of it. These tend to be a little bit more accurate than the medium range forecast, just because it's closer to the actual prediction, and the more data you have, the better your prediction can be. Typically, short-range forecasts only cover between 12 and 48 hours into the future. So, 12 hours is half a day, all the way up to 48 hours, which is up to 2 days. Medium-range forecasts, on the other hand, show much less information. Because weather's constantly changing, it's obviously very hard to predict when it's constantly changing. So it shows a lot less information, but not less useful information. It still shows us very useful information. Medium range forecasts show us pressure systems and fronts typically. They also will show us isobars as well. And a medium range forecast map shows or covers roughly 3 to 6 days into the future. So a little bit larger of an area or a time frame than the short range weather forecast. Now let's take a look at sky coverage map. This is the expected amount of clouds in percentage covering the sky. So you can see across the top, you can see a little bar that shows us the numbers from 0 to 100, and as well as different colors. So each color represents a different percentage of sky coverage. So this is actually from Tuesday of this week at 8 a.m., and it shows us the sky coverage at that time. You can see that North Carolina was actually relatively cloudy. You can see North Carolina is gray, and it matches somewhere in the 80 to 90% cloud coverage at 8 a.m. this morning. Whereas vast majority of the country had very little cloud coverage in percentage terms. The other type of map on this page is the temperature map. These maps can show the maximum daytime or the minimum nighttime temperature in degrees Fahrenheit. And they too are associated with a scale of colors. So you can see across the top the scale, pink being cold, red being very warm. And you can see North Carolina's in the green to yellow. You can see it in the green to yellow, so between that 50, 60, and 70 degree mark, whereas other parts of the country are quite colder, especially up here in the Northwest, Montana and Colorado area. No, wait, that's not Colorado. That would be, I don't know what state that is. That's bad, ain't it? It's because this one I believe is Colorado. That might be Wyoming, if I'm not mistaken. Anyway, but again, this is from Tuesday, October 13th at 8 a.m. So it gives us a good idea about what the temperature looks like with regards to the United States. Now, what's actually useful too is we know that weather tends to move from west to east. So maybe we could use this weather map to possibly see into the future on the East Coast here what our temperatures might be like in the near future over the next coming days. The next two type of maps are precipitation amounts, which is the quantity of precipitation forecast. These predict and the quantity of precipitation, whether it be snow or rain, and it covers typically 1 to 3 days into the future. This one just happens to be 1 day or 24 hours, and what you'll notice here's the scale on the left, and that is measured in inches. And you can see the different colors represent a different amount of precipitation. Light green being very little precipitation, and like a yellowish pink color is quite a significant amount of precipitation. Typically, it'll stay within the 2 inches and under for most days, unless there's a severe storm brewing. You can see actually the northeast of the United States is actually getting quite a good amount of precipitation on this past Tuesday and Wednesday. The next map on the right-hand side is the chance of precipitation. This is the likelihood expressed as a percent that a precipitation event could occur in a region. So this is a little bit more generic, helping us just kind of determine, well, is there going to be rain or not within the next 12 hours on this map? And this will tell us the next 12 hours on October 13th, which was Tuesday. You can see different areas. You can see across the top, again, is our gradient bar that tells us what each shade of green represents, and tan meaning nothing or zero or little chance, whereas darker green means high chance of rain. So you can see that these two maps actually line up quite closely when it comes to the chance of precipitation in the areas where they predict the amount of precipitation. So, it really lines up with these two maps for this instance, and typically they do. The next map is the wind speed and direction map. This measures the sustained wind speed and expected wind direction. Okay. Again, this is from October 13th. All these are. But you can see these little symbols here. And these little symbols point in the direction that the wind is blowing. Okay, so let's actually find one right off the coast of North Carolina there. It is pointing northwest there. And each symbol has a different wind speed. So they don't write the numbers there. They typically use these symbols. And the you can see also that there is a color gradient to kind of help us out across the top there. Red would be more than 40 miles per hour with wind speed. I put a chart over on the right-hand side to show you the different speeds in knots, which is typically what it's measured as, and miles per hour, so that you guys have a better understanding of how fast that is, and what each symbol represents in speed. Typically, you will see these first 3 or 4 symbols, but when storms come, you can definitely see some of the larger symbols. The next thing I want to talk about is Doppler Radar. This will pop up a lot in local news stations when there's a severe weather event like a thunderstorm or something. They always seem to brag about their Doppler Radar. A Doppler Radar looks exactly like a white volleyball or a soccer ball on a tower. And what it does is it actually determines the direction and distance of objects. It sends out radio waves and listens for the bounce back, basically. And it helps to detect storms and how they're moving and what is actually in them. It can actually detect hail and things like that. It can detect precipitation intensity as well as wind direction and speed, and it can give us a good idea of the size of the hail as well as how much rainfall could occur. Doppler radar is extremely important in predicting weather, severe weather such as thunderstorms, and possibly give us an idea of where tornadoes might form, so that we can warn people and get them out of the area, or get them to shelter in place if possible. So I put a weather map there of last year when a severe thunderstorm line came through North Carolina, and you can see that the red and the oranges are severe precipitation, and the yellows are in the middle, and then greens and light greens are weaker precipitation. So the reds are where the storm is very, very strong, and the rest are a little bit less. That is it. I hope that you enjoyed this presentation. If you have any questions, I am still in the Google Meet to assist you. Have a great rest of your day. Thank you for taking some good notes. And sorry for my dog, Nico. He's barking at someone or something.